Welcome back, and I'm back in the prep room today because I rather like the backdrop in here, so it's a nice place to film. What I'm going to show you today is a really interesting experiment, and it's one you can try at home, and all you need is a chocolate bar, and in this case a Twix. And then all you do is just put your drink down on the bar and you leave it alone. I'm not sure you expected that to happen, and neither did I. So let's try and explain what's happening. Electric fields apply forces to charges. Why does putting two transparent things on top of each other do something so strange when you turn it through 90 degrees? You'll notice that Laika the dog's not with us again. She's off on another one of her world travelling missions, and more of that at the end. So, I said I've got a simple experiment for you to do today, and one to try at home. And this one works best with a Twix bar. What you need to do is put it in the fridge, not the deep freeze, but just put it in the fridge. And what we're going to do is we're going to look at what happens, not when you eat it, but when you take one of these Twix bars and you bend it. So, I've got a piece of Twix out of the packet, and what we're going to do first is just bend it gently. So I'm going to apply forces to the sides and bend it and bend it and bend it and bend it, and you can see the toffee coming out there. Delicious, I'm going to eat this in a minute. And I suppose that behaviour is exactly what you expected. But it's the second experiment I'm going to do that might surprise you. So now for the second experiment. Take another piece of the Twix, put it on the edge of the kitchen table and hit it really hard with your fist. 3, 2, 1. And you'll notice something completely different happened there. So you might have seen my experiment on non-Newtonian fluids, and this is sort of another example of that. The toffee in the Twix behaves differently with shear forces, depending both on the magnitude, the size of the force, but particularly how rapidly it's applied. And if you apply the forces gently, you find that it behaves in a sort of ductile manner. The toffee sort of stretches out slowly and flows and runs. But if you hit it very rapidly with a shock force, it does something completely different. It breaks just like glass would. So here's a close-up of the bit that broke just like glass. And if you look, the surface is completely flat. The toffee didn't have any chance or time to run to be ductile. It snapped just like something that has a brittle behaviour. Whereas the first one I bent with the more gentle forces and not shock loading it, you can see that toffee has had time to run and stretch out. It behaves much more like a ductile material. So, I do hope you enjoyed that experiment, and do try it at home and let me know in the comments how you got on. All you need to do, if you remember, is to put the Twix bar in the fridge. There's no need to put it in the deep freeze. Anyway, I'll see you again next time.